This is our war. And this is our plan of attack.
Banks have become an essential threat to our democracy. So consider this justice.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
It's go time, everyone. Welcome to Collision Course. My name's Francis Walsh. I welcome you this evening. Hello, Chuck. I know you're out there listening. Hello to all my friends who will make it to the show, who are maybe listening to it live or maybe listening to it later. This is your next episode of Collision Course on Revolution Radio. It is Saturday, November 24th, 2018 at 6 p.m. in New York City. We're going to talk about the Parker Solar Probe. In about a half an hour, we're going to have a very interesting and informative interview with Professor Marco Velli. He plays a major role in efficiency and theories over at the Parker Solar Probe, and we'll get into that in a little bit. But for right now, I want to wish you a good evening. I hope you all had a wonderful Thanksgiving where you are, or a celebration if it was for you, and your time for celebration. I hope you had a great one. The Walshes had a wonderful family gathering and meal. And now we're on our way to the next holiday, Christmas. Merry Christmas to you. I hope that you'll be ready. We're going to scramble all the way to the end of the month and enjoy this holiday season, this Christmas season, as much as possible. I don't see any reason why not. No reason at all. But let's get back into outer space. Let's take a ride outside our atmosphere and toward the Parker Solar Probe, because that's what we're going to be talking about tonight. Everything about Parker Solar Probe will be revealed to date. This is going to be a mission that will last all the way into the mid-2020s, 2024. This mission has 24 Perihelion approaches to the sun. That's right, 24. This mission has 7 flybys of Venus. And we'll get into those shortly. Let me first, though, because this is a report of the happenings outside our atmosphere, let's talk about the things I love, and that's asteroids and comets. First off, Comet 46P Wirtanen. This week on November 14th, from the dark skies of central Texas, where Cosmic Obsession Kerrville is located, our good friend and astronomer Bob Fitzhenry took pictures of 46P Comet Wirtanen for us. And as I'm looking at the orbital diagram for our Comet 46P Wirtanen, I recognize a couple of things that with this, as I looked at it, were a little different to me. And so this is a new type of orbital path that I am not as familiar with. You say, well, what does that mean, Francis? What do you mean, an orbital path that you're not quite familiar with? Well, this orbital path, if we know how comets operate like this. The closer they come to the sun, the more reactivity they have because of its close encounter. Now, for a long period of time, I've looked at comets who have come close to the sun, even too close to the sun. Comets like Comet Olenin, a couple of other ones that I'd have to look at to get the names right, but Comet Olenin's right off the top. That came too close to the sun, and in its passage it disintegrated or disappeared or was evaporated. But with 46P Wirtanen, the orbit is at closest approach to the sun, very close to Earth's distance from the sun as well. Right today, and I'll click back, and I'm going to have to click back to today. It is, oh, no, I sent the wrong one. It is, totally sent wrong. Well, what's special about it is that for its closest approach to the sun, it appears to be quite close to Earth. And at its closest approach to the sun, or let's put it this way, during this time, the closest approach to Earth is a mere 7 million miles away, 0.078 AU away from the sun. So on one hand, with Comet Wirtanen, 46P Wirtanen, the scientists say this object has an opportunity to become a potentially unaided object that we can see with our unaided eyes in the sky. It's a little bit strange to me because its closest approach to the sun puts it out here right around where Earth is quite close to Earth, 7 million miles away. And maybe that is the reason why it might be more visible to us, is because we have an actual close approach to Earth. And we're going to continue to hope on that. But the reason why I wanted to bring it up is because it's an object that's out in the sky, 46P Wirtanen. Comet will be making its closest approach. I believe I went up to December 18th. I think that's the day. So we have from now until then, and then maybe even a little bit after that date, as it's in its closest approach to sun, for an opportunity for the comet to do an increase in outgassing, increase its luminosity, and become an object that we can see in the night sky with unaided eyes. Right now, I believe its location is in the constellation Cetus. Okay, we're going to move on to the next object. There's 46P Wirtanen. I want to thank Bob over at Cosmic Obsession Kerrville for taking the latest images on November 11th. We have the images over on Collision Course from Facebook, facebook.com/Collision Course. We'll go on to the next. The list of close approach near-Earth objects, near-Earth asteroids. We're going to do the top three. 2018 WD flies by November 24th. Lunar distances 4.52. Relative speed 13.60 kilometers a second. Diameter 37 meters to 83. Next, 2009 WB 105 flyby 2018 November 25th at 12:14 UTC. 15.15 lunar distances away, 18.88 relative kilometers per second, magnitude 23, 53 to 120 meters. Then we had 2018 VT7, passes by also on November 25th, 1724 UTC. Lunar distance is 8.21, number that I use, 238,000 miles. That's the number I use. So that would be 8 times 238. Relative speed is rather slow, 2 kilometers a second. Magnitude 27. 7.2 meters to 16 meters, small object. Those are the latest three, 24, 24, and 25. 2018 VT7, Earth distance 0.022 AU, has a relatively flat orbital path, much like the planets and Earth. Next object, 2009 WB 105, Earth distance 0.042 AU, has a highly elliptical orbit, which means it's standing. If our ecliptic plane was flat, from 9 to 3, then the orbit of object 2009 WB105 would be from 1:30 to 7:30. That might represent how elliptic it is. And then we have 2018 WD. This also an elliptic, but not nearly as bad. Earth distance 0.012 AU. And then to get that relative distance, you take 0.012 times 93 million miles, and you'll get your distance at that time. Okay, I'm going to close those down. These are all the near-Earth asteroids, objects. So we have to move quick into our topic of the day, which is the Parker Solar Probe and an introduction to Marco Velli. Let's start a little bit introducing Marco Velli. Dr. Marco Velli has developed codes for the simulation of compressible magneto-hydrodynamic flows using spectral and pseudospectral fast Fourier and Tycho-Bechev methods and compact finite difference schemes for problems with periodic and non-periodic boundary conditions, implementing characteristic boundary conditions, allowing for both reflection-free and or incoming wave boundary conditions. These codes have been used to study diverse phenomena from the evolution of turbulence in the expanding solar wind, the 2D evolution of turbulence in a cross-section of a coronal loop in the Parker scenario, to the parametric decay of large amplitude Alvin waves in a homogeneous and stratified medium, and nonlinear propagation of Alvin waves at magnetic X points. We're talking serious science, which has everything to do with electromagnetism, the solar weather, or the conditions that are expelled off the surface of the sun, solar magnetism, solar loops, solar coronal holes, the temperature of the sun's corona. All his experience is going to be focused through the Parker Solar Probe onto some very specific theories and answers, given the Parker Solar Probe's return of observations. Dr. Velli has taught mechanics, electromagnetism, astrophysics, plasma physics courses at the University of Florence, and mentored 7 students for their laureate thesis in Florence, directed 5 PhD theses at the University of Florence, and 2 at the University of Paris 11 Orsay. He has been member of peer-reviewed committees for NASA research and payload proposals, as well as for ESA, member of the Science Definition Team for Solar Orbiter 2003, and is presently a member of Solar Probe Science and Technology Definition Team, responsible for drafting the scientific objectives and requirements. Dr. Velli was chair and main scientific editor for the International Conference Solar Wind 10 PISA June 2002. He has published over 70 peer-reviewed research papers involving many collaborators, both in Italy and abroad, as well as invited papers and lecture notes. His education is a PhD in physics from the University of Pisa and Scuola Normale Superiore, combined degree, Pisa, Italy, 1985. Research interests. His research areas of research interests are focused on space plasma physics and solar magnetic activity, with particular emphasis on the stability of magnetic structures anchored in the photosphere, such as coronal loops. And for most of us, we should have an idea of what a coronal loop is, because we've all should have seen images of the sun from the solar observatories like SOHO and SDO. When the sun is highly active, we will see these coronal loops, which are just loops of powerful magnetism on the surface of the sun. Research interests include wave propagation and shock formation in inhomogeneous and stratified plasmas, nonlinear evolution of current sheets and magnetic reconnection, the properties of turbulence and dynamic forced open systems, wave particles interactions in the solar corona and heliosphere. A lot of this, again, if we're so inclined to be interested in how electromagnetism works in the solar system, it's going to be these kind of missions that bring the science to fruition, or the science to the forefront, so that we can ingest it, digest it, and come to conclusions about the new science that something like the Parker Solar Probe is going to do. The Parker Solar Probe is a mission that is 60 years in the making. Imagine that. We've yet or haven't or have not sent a solar probe of this kind to the sun, and it's just been in the planning stage for over 60 years. His projects include the Solar Probe Plus. Solar Probe Plus will study the streams of charged particles the sun hurls into space from a vantage point where the processes that produce the solar wind actually occur. And herein lies the Albert Einstein theory of relativity come together. One of the main puzzles that the sun presents to scientists is how the sun is able to accelerate particles from its surface or at its corona at speeds that are far faster than the dynamics of the sun as we know it could produce. That's about as straightforward as it goes. Let's say it again. So what puzzles scientists and bends Einstein's theory of relativity is the effect that occurs at the surface of the sun, which accelerates particles far beyond the speeds that the sun's natural dynamo should create. The exchanging of helium and hydrogen, and the way the sun operates, and what this solar probe is going after, and what our friend Marco Velli is most interested in. I don't know whether he's most interested in that or not, but I would not doubt, because that's something I'm most interested about. It seems to be the science that, for me, would be the first part of the mission that you want to start understanding. Because we understand so little, how do we get the particles moving? How does the sun get the particles moving at such accelerated speeds? And the Parker Solar Probe, through its mission of 24 Perihelion approaches, 7 Venus flybys, and people like Marco Velli observing the data returned, should be able to come up with reasonable answers now to the actual occurrences of the areas of the corona to where the particles pick up their speed. And in the dictate of the information, it says as much. While we're on this, Parker Solar Probe, like I had mentioned, and it plans quite a number of close flybys to the sun. 23, 24, maybe even more. But as of right now, they have 24 on the list of flyby of close approaches. And during that time, we will have, or Parker Solar Probe will have, the Solar and Heliospheric Observatory, SOHO, S-O-H-O, working in partnership with them to probably help keep an eye on the mission as it flies by. SOHO has the ability to see objects close by to the sun, and we're going to get an opportunity to see if SOHO can visualize the Parker Solar Probe as it's making its rounds around the sun. In some information that was released from SOHO, exciting new science opportunities are in store during the Perihelion passes, the point in an orbit where it is closest to the sun. If the recently launched Parker Solar Probe, PSP, it will approach the sun to within 10 solar radii, approximately 6 million kilometers from the surface. For comparison, SOHO's LASCO C3 field of view extends to 30 solar radii, 21 million kilometers. The image below shows the PSP science window where the spacecraft is within 38 million kilometers from the sun. The Perihelion passes in 2019 through 2020 and 2021 to 2022 are shown in red in the image that they show here, and yellow respectively, and the symbols are 1 hour apart. SOHO's LASCO observations will be critically important in assessing the structures PSP will fly through during its close approach, which is quite true because SOHO's main objective is to pay attention to space weather coming directly off the sun. So if there is bad weather, i.e. a solar flare, i.e. coronal hole, increased space winds, SOHO might be able to foresee that occurring. Will they be able to avoid, prevent, go around? I do not know at this time what is available to them to avoid a dramatic change in space weather. So it'll be observing the space that PSP will fly through during its closest approach to the sun. Thanks to the extremely well understood performance of LASCO C2 and C3 telescopes, LASCO will also provide a uniquely reliable way to cross-calibrate the photometry of PSP's heliospheric imager, WHISPER. Joint observations between PSP and SOHO's payload will shed new light on how the sun connects to Earth in the solar system and the heliosphere, with PSP measuring the nascent solar wind and the onsets and properties of solar particle events close to the sun. SOHO will provide the near-Earth perspective and allow us to understand how solar wind streams expand and fill the heliosphere. It will also provide a unique view about how solar energetic particles diffuse across the frozen interplanetary magnetic field. A long-standing issue in heliophysics research, and again, there it says a long-standing issue. We have issues with particles, speed, and interplanetary magnetic field. For the first time, scientists will be able to obtain long-awaited concurrent, close to the sun and near-Earth observations, which will also help set the stage for ESA's next solar and heliospheric physics mission, Solar Orbiter. So we have SOHO LASCO partnering up with Parker Solar Probe. We'll be able to go on to SOHO when the close approaches are made and actually watch as the probe comes by. SOHO will also watch for space weather during those times. Okay, as we're leading up into the break here shortly in a few minutes, about 5 minutes, I want to bring this up. Are we witnessing the start of solar cycle 25? Is it perfect timing for the Parker Solar Probe to be out orbiting the sun? Because as of recently, we had some activity on the sun, which for those scientists who are looking for anything to bring on or bring us out of this solar minimum, or Maunder minimum, some might think it might be a Maunder minimum, to bring us out of this solar minimum, they're hoping that some of the sunspots seen recently could give us a pathway to the start of solar cycle 25. What's up with the sun? As these scientists have said previously, the sun isn't doing what the sun isn't doing is the biggest news in 2018 in solar astronomy. Now the sun sent scientists a curveball the past weekend with a strange tale of growing sunspot AR 2720, and this was a couple months ago. So I just want to get into this because I'm going to pose this question to Marco. So this article does ask the question, are we going into a solar maximum? I will ask the question to Marco when he gets here, what his view of the solar maximum / solar cycle is to him. But we'll read this. We're currently headed toward a solar minimum forecasted to arrive in 2019. As the sun switches over from solar cycle 24 to solar cycle 25, the sun goes through 11-year cycles during which solar activity increases and ebbs in a somewhat predictable fashion. Tracking this activity goes all the way back to the start of the ground and space-based operations that monitor the sun around the clock. As a technology-dependent society, it is important to know that what the sun is doing. Solar flares can spell the bad day for GPS. Okay, we're going to be coming up on this break. We can come back to this article after, but we're going to go ahead and we're going to let Marco Velli give us his interpretation. This article is pointing at a series of but it goes over a bunch of different scenarios from a bunch of historic solar cycles, and I'll keep that up there so we can revisit that. Parker Solar Probe. NASA's Parker Solar Probe mission will revolutionize the understanding of the sun. Parker Solar Probe will provide new data on solar activity and make critical contributions to science's ability to forecast major space weather events that impact life on Earth. Mission, measurements from within the region where all action happens. On the final 3 orbits, Parker Solar Probe will fly within 9 solar radii of the sun's surface. 9 solar radii is 9 times the radius of the sun, or about 3.83 million miles. That is about 7 times closer than the current record holder for a close solar pass, the Helios spacecraft. At closest approach, Parker Solar Probe will be hurtling around the sun at approximately 430,000 miles per hour. That's fast enough to get from Philadelphia to Washington, D.C. in 1 second. At closest approach to the sun, while the front of Parker Solar Probe's solar shield faces the temperatures approaching 1,400 degrees Celsius, the spacecraft's payload will be near room temperature. Launch, August 12, 2018 at 3:31 a.m. Launch vehicle, a Delta IV Heavy with upper stage. Parker Solar Probe will swoop within 4 million miles of the sun's surface, facing heat and radiation like no spacecraft before it. To get there, it takes an innovative route. Trajectory design. We'll talk to Marco about the trajectory design, where that all came up. Where's the science behind that? Final solar orbit. At closest approach, Parker Solar Probe will be hurtling around the sun at approximately 430,000 miles per hour. That's fast enough to get from Philadelphia to Washington, D.C. in 1 second. Closest approach, 3.83 million miles. Speed, 430,000 miles per hour. Orbit period, 88 days. Where is the Parker Solar Probe? Okay, and I'm reading this from the Parker Solar Probe page. It's parkersolarprobe.jhuapl.edu. And it has a whole long page with all the different sections to it. And it actually shows you where the Parker Solar Probe is right now. Has a timeline. 2015, Critical Design Review. 2016, System Integration Review, July, KDPD, July, Start of Integration and Testing. Begin March 2017, Instrument Deliveries, begin August 2017, Observatory System Testing, Fall 2017, Shipment of Observatory to GSFC. 2018, Spring 2018, Shipment of Observatory to Cape Canaveral. August 12, 2018, launch, 3:31 a.m.
We'll be right back.
October 3rd, 2018, Flyby Venus number 1, 4:44 a.m. Okay, on the other side of the break, we're going to have Marco. Stay with us.
When I knock
post-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. Yes. But all the decisions of that officer have to be ratified at a special bi-weekly meeting. Yes, I see. By a civil majority in the case of purely internal affairs. Be quiet. But by a 2/3 majority in the case of more quiet. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, and stupidity.
I'll do you for that. Oh, what? Come here. What are you going to do, bleed on me? I'm invincible. You're a loony. The Black Knight always triumphs.
Roundtable Live Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us here at Revolution Radio, freedomslips.com.
Enjoy your
extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another?
Extra big-ass fries.
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase.
No.
I'm sorry you're having
trouble.
Come
on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What are we doing live? It goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free. But there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. Welcome back. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no less. Revolution Radio, where information never sleeps.
Important role on the culture.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to
the sun's space weather and how it operates.
Sure. So Parker Solar Probe is a mission that's going to go and explore the solar corona. The solar corona is the place in the sun where the sun's magnetic field, the energy in the sun's magnetic field, dominates all other form of energies. To be clear, life on Earth depends, of course, on the sun's radiation. And most of the energy from the sun comes in radiation. Only a few percent of a thousandth, a few thousandths of a percent of the sun's energy goes into magnetic field. But the problem is that the solar corona is very, very hot at about 2 million degrees, some areas even much hotter during solar flares. And therefore, because it's so hot, it expands outward into interplanetary space, filling a bubble, in fact, in the interstellar medium, which is called the heliosphere. We don't really know how it is that the magnetic field ends up heating the solar corona and then accelerating the solar wind, which is a flow that actually hits the Earth. We are alive on the Earth only because the Earth has a magnetic field, which protects us from the energetic particles that are flowing with the solar wind. And it's not a perfect shield. Sometimes when there's a big magnetic storm, we have a lot of influence on the Earth and on satellites, of course. But as a spacefaring society, if we ever want to go further out, we really need to know how to predict and how to defend from these energetic events on the sun. So Parker Solar Probe is not a space weather mission per se. It's a science mission. And its goal is to go and make fundamental measurements to really understand how currents and magnetic fields provide energy to the very light gas, to the very tenuous gas in the solar corona, heating it up to such energies. And it's very similar to what we're trying to do on Earth, to use magnetic fields to confine what are called plasmas, hot gases where ions and electrons are separated because of the high temperature, are called plasmas, and we try to do controlled nuclear fusion on the Earth. Well, the solar corona is a natural plasma, which heats up the gas to 2 million degrees, and some of the similar instabilities occur there too. So as soon as we discovered space and we discovered that there were energetic particles coming from the sun, back in the late 50s, it was thought that we needed to go there, and that hasn't changed. Only that we needed major technological advances to be able to send us probe to the sun, and we actually did launch the Parker Solar Probe, which is going to go up to a distance of about 10 solar radii from the solar center. That basically is 7 million kilometers, or around slightly less than 5 million miles from the center of the sun. And it was launched on August 13th of this year, and it's actually had its first flyby of Venus and its first closest approach to the sun. It winds its way into the solar corona by multiple passes around Venus. So we launched it. It went to Venus. Venus slows it down so that it can fall further in. It's very hard for a spacecraft to go so close to the sun because it's moving so fast around it with the Earth. Anyhow, we've had our first closest approach halfway the distance of Mercury to the sun, 35 solar radii or so, in November, beginning of November, and we'll start receiving data from that first encounter, which is going to already teach us a lot because we've never been so close to the sun, just at the beginning of December. So anyway, that's the goal of Parker Solar Probe. It has a suite of instruments that are dedicated to really basically understanding, by making direct magnetic field measurements, direct measurements of the gas, the particles, the electrons, and the protons, measuring the electromagnetic field fluctuations, measuring the magnetic field, and measuring the spectrum, so-called, of energetic particles, how much particles have so much energy as a function of time and distance from the sun. So those are the instruments on the probe. And, of course, I'm more of a theoretician. I'm the theoretician of the group. And my goal is to put together a lot of these measurements and try to figure out what's going on and how these may falsify or verify some of our ideas as to what's going on. So that's, in short, that's what probe is about.
That's a short for a whole lot of work. We can attest to that. Now, I wanted to step back and just make sure my listeners understood. From the Parker Solar Probe, it has periods of time that it transmits its observations. That period of time would be when it's farthest away from the sun. Is that right, Marco? So it's taking, it gets close to the sun, and it's taking readings and observations, and it's at its most risk. It's not too much concerned with sending back information. It's just doing its science. So then once it gets out...
Yeah. I said it's very hard to transmit signals very far away. Remember, it takes signals 8 minutes to get from the sun, but if a spacecraft is in between the sun and the Earth, the noise from the sun dominates over everything else. So it's very difficult to have an antenna that would be large enough. The antenna, remember, has to fit behind the shield so that it's in the umbra of the spacecraft. So it's not very large. So we need to wait for the spacecraft to come out further and closer to the Earth. In fact, it's not enough that it's far away from the sun. If it's on the opposite side of the sun, which happens, once, every other perihelion, basically, the spacecraft has any kind of arbitrary angle, so it can be on the other side of the sun with respect to the Earth, and then it can't transmit back. So we have to wait for it to get close enough to the Earth to be able to transmit. So our next real information pass begins at the beginning of December.
Could you give us any insight into how we use Venus to slow the spacecraft down rather than speed it up?
Well, the idea is imagine that you are throwing a ball up into the air, for example. It will go up and then it will fall back down, right? So that's how gravity works in general. Now, Venus is speeding around the sun faster than the Earth. So if you send a spacecraft towards Venus and you let it catch up with Venus from behind, then Venus will kind of do the same thing. It will attract it to itself, and it will kind of ricochet off Venus. So from the point of view of Venus, it's going to be arriving from the back, and then it's going to go around Venus and be kicked backwards by Venus. So from Venus' point of view, it's accelerating it. But Venus is actually going around the sun really fast. So in the frame of the sun, it's actually slowing down.
Right. So it's all relativistic.
It's all relative. So imagine Venus as a ball slowly moving around the sun. Imagine spacecraft zipping and it kind of catches up with Venus from behind. And from Venus' point of view, it just does like a parabola going backwards from Venus.
Right.
But since Venus is moving around the sun, it's actually not going backwards, but slowing down so that it can fall to the sun more easily. You really want to be able to fall on the sun. If you're at the Earth and you could just stop the Earth in its track, then it would fall straight on the sun. Okay? But the Earth is moving at about 20 miles a second. Okay? About 20 miles a second around the sun. That's really fast. So we can't send the spacecraft directly to the sun because we can't stop it. Whatever leaves the Earth more or less moves at 20 miles a second. Around.
So you basically have to put speed bumps. Well, Venus is a speed with its mass.
Every time we catch up with exactly. Every time we catch up with Venus from the behind, it slows us down just a little bit more, and we fall a little bit closer to the sun.
Right, because the influence of Venus takes a hold of the spacecraft.
Yeah,
and
Venus steals energy from the spacecraft, and so it can fall.
I came up with what I think is an interesting question. Okay, clocks and mass and objects like the sun. I just happened to today fall upon an article which spoke about the range of speed of a clock the closer you come to a star.
Yes.
And I'm thinking about this mission, and I'm thinking about the technical side of it. Is there consideration or something that works with the timing mechanism inside the spacecraft that either accommodates that change in relative?
Okay. Yeah, that's a really good point. Well, interestingly enough, what we really need to know as a space, we need two things. One is we need to synchronize the measurements. We want to know the particles that we measure at the same time that we measure the magnetic field, right? So there's a clock which is running on the probe, which synchronizes all the measurements. Now, even though that clock, because of gravity of the sun, can slow down a little bit with respect to our clocks, that doesn't change the synchrony because all the instruments are on the probe. Mm-hmm. So that synchronicity is preserved generically. Then the synchronicity between the clock on the probe and the clocks on the Earth is provided by the transmission of the signal itself and the ranging of the distance of the spacecraft. And so we can actually correct for the time changes of the clocks on probe in that way.
I just found it very interesting. And for my listeners, they love interesting kind of tidbits of information. And that's a perfect one. Here we are in our own solar system, dealing with our own sun, with our own spacecraft, and we've got to worry about whether the clock is going to run slower the closer it gets to the sun or not. And in fact, it does. It does.
Yeah, it does. It runs a little bit slower.
Another theory question from me, because this is for me. When I think of the whole mission, and I'm just going to simplify it into the big question.
It might be interest to your it might be of interest to your readers that the fastest speed of the probe, the probe is going to go at about, I'm going to say it in kilometers because that's the speed of light is about 300,000 kilometers per second. This is going to be the fastest probe. Actually, it already is the fastest probe ever created by man, but not thanks to us, thanks to the sun's gravity that's pulling it in. But it goes at about 2/3 of 1,000th of the speed of light. Okay, so it's about 60% of 1,000th of the speed of light. That's just going to be its fastest speed. So
400.
So the ratio. Yeah, so the ratio between the speed of the spacecraft and the speed of light is a little bit less than 1/1,000, but that's really fast compared to anything macroscopic that we've ever built before. And yeah, so it is the fastest spacecraft ever. There's I
don't know if it's new or not. In my vocabulary, there's a new word that I use, and it's called a flyby. It's going so close. It's going so close to the sun, and I played a little bit of a role in a comet back in 2011, Comet Olenin. Since about that time, we've had a few or a number of comets that have come so close to the sun. Besides the sun grazing ones, which NASA's solar probe will become one day, and we'll talk about that in a second. Having worked with some of these comets, that when the closer you get to the sun to use its gravitational force to get somewhere, it gets a lot hotter. And rather than a flyby, they're called flybys. And I have another, at the end of the show, I've got a real interesting question. But, okay, so right now, for everybody to put a mental image into their head, what we have is the spacecraft was launched in August, and it had to go, and it's already made one close approach past the sun. Right now, it is located somewhere in between Venus and Earth, I believe, in its orbit. You can go to the Parker Solar Probe information page, the main page for the Parker Solar Probe information, and they have a whole bunch of information, including where the solar probe is right now, what the mission is all about. It breaks down the different instrument packages now, and that's something else that Marco plays a major role in. Now, you have a number of instrument packages, which comes with them a number of investigative teams that are operating within those parameters of the package.
Right. So there are basically four what are called instrument suites, because each sort of suite is comprised of more than one instrument. So we have the field suite, which is the electromagnetic fields. It has 4 antennae, which are basically facing the sun. The spacecraft has a solar shield, which protects it from the sun's radiation, and then 4 antennae popping out of the shield, which measure the electromagnetic fields in the plasma. And then on a boom towards the back of the spacecraft, there are magnetometers, which measure the magnetic field. Okay, so that's one instrument suite. It just measures the electric and magnetic fields in the solar winds and in the solar corona. It's called Fields, and the principal investigator is Stuart Bale from the University of California in Berkeley. Then there's an instrument suite which is called SWEEP, which means solar wind electrons, alphas, and protons, and that's made with particle detectors. The particle detectors are mostly sitting in the ram-facing side of the spacecraft. I mean, the shield. You could imagine, some listener might say, well, wait a minute, if you have a shield in front, how are you going to measure the particles coming from the sun? Well, we're going so fast around the sun that it, just like the rain on your windshield seems like it's coming from the side rather from above. It has like a diagonal motion. Well, exactly in the same way, the wind is going to be coming from the side. So even though the sun is blocked, the particles in the solar wind is going to be coming in from the side of the spacecraft. And so most of the particles will be captured by an instrument which is sitting in the shade at a room temperature, basically, and it'll measure the energy and the density of the electrons. Alpha particles is simply helium, which has been all the electrons have been thrown out, so they're called alpha particles, but it's actually helium nuclei, and the protons, which is the nucleus of the hydrogen atom. But there are also some very fast energetic particles coming straight from the sun, and those are captured by the only other instrument which actually faces the sun, which is called the Faraday cup. That's sitting in the solar light, and that's the only instruments with the 4 electromagnetic field antenna. This Faraday cup was built especially to be able to resist, over 600 suns, which is, how close we're going to go. It's going to be like having 600 suns in the sky.
Right.
So the principal investigator is Justin Casper, Professor Justin Casper from the University of Michigan. We then have an instrument which is really 2 white light telescopes, like coronagraphs, and it's really a white light imager. And the principal investigator is Russ Howard. It uses the shield as an occulter, like at the solar corona. You have to block the sun to be able to see the corona.
Yes.
Well, this instrument uses the shield. It uses the heat shield as an occulter to observe the solar corona in the direction in which the probe is going.
Yeah, it has an aperture that's larger than that. Okay.
Yeah, and so it's basically made of 2 telescopes because, believe it or not, the electromagnetic field antenna reflect light, right? So they would have been very bright lines, and so we couldn't build 1 telescope. We needed 2 telescopes so that we don't have the antenna in the field of view to avoid the bright light. So
that's
it's actually
smart.
2 detectors, and that's working perfectly. There are some images on the website. You can go on the website is parkersolarprobe.nasa.gov. And you can see some of these images already. And Russ Howard from the Naval Research Laboratory is the principal investigator. The final instrument suite is dedicated to measuring the spectrum of really energetic particles. These are the cosmic rays that are generated both at the sun and the solar corona during major storms like solar flares, and also accelerated by shocks inside the solar wind. So this is called ESIS. And this instrument measures the whole spectrum of the energetic particles. These are the particles that are kind of called killer particles. They're the ones that we need to protect astronauts from if we're flying in space. They're the particles that when there are too many of them, when the flux goes way too high, then you have to put your satellites around Earth orbit into safe mode to protect them, or your GPS will go haywire and things like that. And these mostly are generated during intense magnetic storms in the solar corona. And the principal investigator is Dave McComas, who is professor of physics at the University of Princeton.
Yeah, I've had the pleasure of interviewing Dave McComas with his work with IBEX and the energetic neutral atoms at the heliosphere and at the magnetosphere. I find that totally enthralling and interesting as well, because because we have to understand reconnection, disconnection,
right?
What's occurring? Go ahead.
Yeah, that's thanks to IBEX. We've learned about the direction of the interstellar magnetic field around so the Earth has a magnetosphere which is sitting in the solar wind. The solar wind blows a huge bubble into interstellar medium, which is called the heliosphere, and how particles come into the heliosphere from other stars and from other energetic events depends on the relative orientation of the magnetic field in the interstellar medium from the heliosphere itself. And we've learned a lot about that thanks to the IBEX mission as well. But Probe is really dedicated to understanding the magnetic field as it extends outward from the sun into interplanetary space.
Okay. Now, I'm going to preface what's going to happen. In about 3 to 4 minutes, it's going to go to a hard break for 6 p.m. That's going to carry us all the way back over to about 6:02 or 6:03. I'm not going to have you for much longer than that. It'll be about another 5 or 6 minutes. But when we do get to that moment, and I'll say, Marco, we're going to go to break for about 5 minutes, just to give you an alert, okay?
Sure.
I have this question because I read an article recently, and maybe today or might have been yesterday. Are we witnessing the start of solar cycle 25?
Go ahead.
Go ahead.
Sorry.
Well, of course, with the Parker Solar Probe, you want to have an idea of what kind of situation you're going to be dealing with the sun. And interesting enough, we're at a period in the solar cycles where we need to discover whether we're going to continue in our solar minimum of cycle 24, or if we're going to come out into a solar cycle 25, right? Or did I
That's right.
have said that?
No, that's exactly right. Solar Probe was designed to work both at solar minimum and solar maximum. We know that we've had very weak minimums over the past 2 solar cycles, so we're in a very deep minimum right now. Predictions vary because the solar cycle average lasts about 11 years, but it's chaotic. They don't all last the same, and weaker cycles tend to last a little bit longer than stronger cycles. We don't even know how high the activity is going to become next cycle. In any case, we're slowly coming out of solar minimum. Some predicted that this would happen in the spring, but we have now some initial observations that appear to show that we're rising slowly out of it. But we're going to be measuring with Solar Probe all the way into the year 2024, 2025, hopefully all the way up to 2030. So we should be able to see the solar wind throughout the solar cycle itself.
Another question. In the event of some sort of activity on the surface of the sun, are there evasive maneuvers that can be done by the Parker Solar Probe?
No.
We're stuck with the orbits, right?
We're stuck with the orbit. The only thing that the probe will do if things get really intense is it will shut the instruments down and go to what's called a safe mode to protect the instruments. But, we've designed this spacecraft so that it will withstand, coronal mass ejections, and we should be okay. In fact, that's what we want to measure, so hopefully we should be okay.
Okay, I'm going to shoot off another question. Soho Lasco and the Parker Solar Probe working together?
Well, we need... Solar Probe only has this one white light coronagraph that I was telling you that has this limited field of view towards the direction in which the spacecraft is moving. But, the spacecraft goes all the way around the sun. So we need information because otherwise we don't know.
We're at break. I'm sorry, Marco. I'm going to put you on pause because we're going on break.
No problem.
I will be back talking to you in about 5 minutes.
Sounds good.
We'll see you on the other side.
Radio at freedomslips.com, and we'll be right back after this message.
Narco-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. Yes. But all the decisions of that officer have to be ratified at a special bi-weekly meeting. Yes, I see. By a simple majority in the case of purely internal affairs. Be quiet. But by a 2/3 majority in the case of more... Be quiet. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, and stupidity.
I'll do you for that. What? Come here. What are you going to do, bleed on me? I'm invincible. You're a loony. The Black Knight always triumphs.
Roundtable Live Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us. Here at Revolution Radio, freedomslips.com.
Enjoy your
extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another?
Extra big-ass fries.
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase.
No.
I'm sorry you're having
trouble.
trouble.
Come on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need as humans to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life, it goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free, but there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Thank you, everyone. Thank you for joining us on Collision Course tonight, November 24th, 2018 at 7:02 p.m. in New York City. I have Marco Velli on the line. Marco, are you there? And thank you for waiting.
I am here, yes.
Wonderful. Last little tidbit, because I'm not going to hold you for too long. I never try to overstay my interview. We have Parker Solar Probe reports first telemetry acquisition of science data since Perihelion. So, since the first Perihelion, there must be some good news that you can relate to us about how everything went.
So things went extraordinarily well. There are no major issues. We have received a little bit of data. The only data that we've really looked at has to do with more with the Venus flyby. We haven't taken a look at the perihelion data yet because that's only going to be arriving in the upcoming days around December, mostly around December 10th is when our data will be coming back. But we have received the basic packets. The instruments have all been commissioned, and the beacons from the spacecraft have told us that all is well, and everything is working actually better than right after launch. So things are going well. If you wanted science, I can't give you that yet, unfortunately.
No, that's okay. It's just the probe is going to be on its mission for a number of years.
Yes.
It's best to start early, and I've told my listeners it's best to start with this information source from the beginning, so that we don't get a few years down the road and somehow have lost what happened in the beginning. And getting a first report of all systems go is about as good a report as you can get.
That's right. So if you stay tuned, after the American Geophysical Union meeting, we'll have a press conference, which is going to be the week between probably December 10th or 11th, actually the 12th, 11th or 12th. And our data actually is going to be coming back the week before that, so it's around December 5th. But, if you want a brief update anytime after that, you can ring any one of us PIs on the solar probe mission, and we will be very happy to let your listeners know.
Yeah, and I believe I found a page, too, which details whenever there's an update or a conference or some information coming out from the team. There's a page, and I'm going to share that. Just like one of our listeners going into the end of the break, I hadn't seen this from NASA.gov thumbnails, image, solar wind, corona timeline, Newell and NASA ID. They have a real nice, what would be a PDF, which goes through the timeline for the Parker Solar Probe launch.
Oh, yeah, it's a very beautiful. Yeah, that's a very beautiful PDF. It actually almost looks like a poster. It's really nice. Yeah. Yes,
and I want to thank Chuck. Chuck, one of our great listeners. He said, "Well, wait a second. Have you seen this yet?" And it's how a lot of I'm lucky enough to say that I have a great network around me. And what I try to do is I try to bring great people like yourself into the network, and then the network that I'm working with, they first take all the information in, they eat it up, and then they include their information. So it's just like. What I like about science is just putting a bunch of brains together and creating that hive. The hive mentality works very, very well. But
the beauty of the go ahead. Sorry.
No, go ahead. The beauty is
that the data will become public very fast, and this really is an effort for everyone. The science belongs to everyone, and generally belongs to all the people that have helped to produce it, but it also belongs to the public, which is actually funding most of this science. And in the end, it belongs to all of humanity.
And I always remind listeners that Carl Sagan had that famous saying that it's up to us. It's up to us, the listener, people like myself, in what our capacity can be. And whatever your capacity can be, go out there and reach out to science, whether it be astronomy, whether it be physics, whether it be this, that, or the other thing, because you can, as a citizen, put your hands in some of it and play a part. It's not a hands-off deal. It's not always waiting for somebody to tell you what's going on. Right from the beginning, Marco, when I was dealing with comets, I was getting a bad story. And I had to go out and I had to take a physical picture of the comet myself using a robotic telescope so that I could go back and say, no, this is what it is. And that's how science works. It's a give and take. And so that's why I'm so thankful, and our listeners are so thankful to people like you who give when we ask. And we have a great relationship, and I will come back when I'll pay attention to the Parker Solar Probe, and my listeners will. And when they want to know, I'll reach out to people like yourself. And like I said, our interview is just about over. And in fact, it is over so that you can get back to your busy life and your holiday and your family and friends. And I want to thank you very much for joining us tonight on Collision Course on this November 24th. Is there anything you want to ask of me? If there is, I can answer it.
No, I just want to thank you all, and I just want to repeat what I just said, which is that the mission and the science belongs to everyone, and I hope you're able to enjoy it and take part.
Wonderful. And I'm just going to let that sit for 1 second. Marco, I wish you a wonderful evening. You can just go ahead and hang up on me, and then in the future, I plan to speak with you again. So you have a wonderful time until I speak to you again, my friend.
Okay. Thank you. Bye-bye.
Bye. That's it. That's how you have an informative interview. That's how you reach out to science. Now, sure, I could bombard a scientist with the questions that some people have to know now. But I'll tell you that the scientists, you have to get them to warm up to you before you can ask some of the really tricky questions. I tried to ask some tonight, but they were straightforward. They were science. They related to the Parker Solar Probe, and he was happy to answer them. He even said, everyone, get involved. It's your place to get involved. We thank Chuck for sending us this PDF. I'm going to go back to see Chuck. Hi, Chuck. I looked at the PDF. You like to help the Earthlings. Yes, we need help. We need good aliens like you. Nah, the good ones. The ones that are short, gray, big eyes. Aliens like me. Aliens like you, the listeners. Because we got to be a little bit alien to want to really dive into this stuff in outer space. But it's not. It's fun. The science is interesting. Tonight it was about the Parker Solar Probe because over the next 6 years, we're going to be having to listen to what it tells us because it's about science. It'll be giving us news that we don't know. How do particles get accelerated at the surface of the sun? I believe once we go back and listen to the interview, Marco gave us an insight into what happens. Coming up on a future episode, I'm going to tie in all my interviews. I'm going to tie them all into one segment, and we're going to run back over all the interesting things that each interviewee offered up. Because I can tell you that each interviewee that I have interviewed for season 2 of Collision Course has told me something I didn't read in an article up until that time. And that's simply amazing. And in fact, last week, with Dr. Avi Loeb, after he said what he said on my show about the relativistic speed of Oumuamua, the next day he wrote 6 strange things that we need to know about Oumuamua. And it just happened to be the 6 things that he talked about on the show with me the night before. It was interesting to me that it was the things that he talked about the night before, and he wrote it the next day. Now, I don't know if he found what he said to be so interesting that he had to write about it the next day, or if he wanted to be out there and make sure that it was in black and white. I don't know. I'll have to go back on that. But for tonight, I'm going to click. Let's see. Let's go over there, Chuck. Thank you. Thank you, Marco. Thank you, Chuck. He appreciates you, too. Just going to go see. Okay, so I'm going to go back into this. Are we witnessing the start of solar cycle 25? Because Marco said, that was an interesting question. Are we going into it? Is that Parker, the reason why Parker Solar Probe was sent now so that it could really catch the most energetic periods of our sun? What's up with the sun? As we've said previous, what the sun isn't doing is the big news of 2018 in solar astronomy. Now, the sun sent us another curveball this past weekend with the strange tale of growing sunspot AR 2720. Yes, 46P, 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 46P. Let's just see. I could 1020. What is this? This is 1124. I could just call Chuck. When I don't know which number it was. I don't know what number your number is, Chuck, or we could just talk about it for this bit. But, yes, Bob already got images of 46P Wharton on November 14th. November 14th at 9:30. He's going to get more images. And imaging comets aren't wonderfully easy. It's a difficult task, and Bob does a wonderful job. He's also taking wonderful images of things like the California Nebula or the Rosette Nebula. All amazing in their own right. I just don't know. Well, let me come back over here. Back to the solar maximum. We're currently headed toward a solar minimum forecasted to arrive in 2019 as the sun switches over from solar cycle 24 to solar cycle 25. Am I receiving a call? Is someone trying to call me? Someone trying to call me through the wrong way. I can't do it through Messenger. I got to do it through Skype. Got to do it through Skype, Chuck. Chuck called me on Messenger, and I'm on Skype, Chuck. But the sun switches over from solar cycle 24 to solar cycle 25. The sun goes through 11-year cycles during which solar activity is increased and ebbs and flows. To start the first solar cycle in 1755, today is simple sketching and counting of sunspot numbers has given way to ground and space-based operations that monitor the sun around the clock. As a technology-dependent society, it's important to know what the sun is doing. Solar flares can spell a bad day for GPS, satellites, and astronauts currently in space. Even airline crew and passengers get a markedly higher dose of radiation during solar storms, especially during polar crossing, transoceanic flights, and even such as the 1859 Carrington super flare would wreak havoc today. As it comes to a close, solar cycle 24 is now the most scrutinized period in solar astronomy, but it has been anything but normal. First, the transition period from solar cycle 24 to solar cycle 25 was deep and profound, the deepest in over a century. 2008 featured 268 spotless days, and when cycle 24 finally arrived, it was sputtering and lackluster at best, only producing a few notable sunspots. Now, the transition from cycle 24 to cycle 25 is on track to top that, with 132 spotless days on the earthward-facing face of Sol already as of August 29th, or 55% of the time, leaving some solar astronomers to propose that if the trend continues, solar cycle 25 may be missing in action altogether. Or will it? The growth of active sunspot region AR 2720 defied the overall trend for 2018 before it rotated around the solar limb and out of view, begging the question, has solar cycle 25 arrived? As a huge ball of gas, the sun does not rotate uniformly, but instead spins on its axis once every 34 days near its poles and 25 days near the solar equator. But how do we know that a new solar cycle has arrived and that a given sunspot is a member? Two factors come into play with identifying that a new solar cycle is indeed underway: the appearance of new sunspots at relatively high solar latitudes, and the reversal of the sun's magnetic field. The first factor can be seen observationally in white light over the span of a solar cycle, and was first identified by Richard Carrington in 1861, and later refined by Gustav Sporer in a law that now bears his name. Chart out the appearance of sunspots over time by latitude, Sporer noticed, and you get a tidy butterfly graph depicting the 11-year solar cycle from minimum to maximum. The second piece of the puzzle had to wait for the arrival of 20th century technology, 20th century technology, for astronomers to uncover it. It was known throughout the 19th century. Thank you, Chuck. Chuck has some company now, so he's going to go and take care of his company. It was good talking to you. Thank you for the link to the PDF. Thank you for listening to the show with Marco Velli and the Parker Solar Pro. We'll see you soon. Talk to you soon. You have a wonderful night, Chuck, with you and your family. And anyone listening, I hope that you're having a great evening with your family and your friends, or with me. The second piece of the puzzle had to wait for the arrival of the 20th century technology for astronomers to uncover it. It was known throughout the 19th century that there was a magnetic component to the sun, as displayed by the electromagnetic havoc and enhanced auroral activity that solar storms could induce on Earth. In 1908, George Ellery Hale, a pioneer in American astronomy, used the newly installed 60-foot solar tower telescope at the Mount Wilson Observatory to note that spicule swirls around the sunspot pairs rotated in opposite directions, much like metal fibers on a sheet of paper in the presence of a magnetic field in high school science classes. Hale used the 9-meter lithospectrograph attached to the solar tower telescope to exploit what's known as Zeeman effect, where a sunspot spectrum shows either a split or a broadening, evidence of its polarity, to deduce the magnetic field of the given spot. Hale showed that the sun actually reverses its robust magnetic field every solar cycle, and the reversal period of 22 years, whereas the same hemisphere returns to the same cycle, is known as the Hale cycle. Likewise, sunspot pairs in the northern or southern hemisphere of the sun show up as reversed in opposition to each other on magnetograms, showing spatial movement of the magnetic fields within the sunspot group, with one dark segment, south polarity, moving inward, and one bright segment, north polarity, moving outward. Remember that swirling action that Hale noted? Well, looking at the magnetogram of a given sunspot, you see either the bright spot leading or trailing the group versus solar rotation. And this flips when the sun's pole reverse every solar cycle. Horace Babcock built and installed the first true magnetogram imager on the 150-foot solar telescope on 1957, allowing him to take the first true magnetogram TV image of the sun, which took the device about an hour to produce. Today, you can see the very latest magnetogram image of the sun with the flick of a smartphone, courtesy of the Solar Heliospheric Observatory, otherwise known as SOHO, and NASA's Space Weather app. Which brings us back to the curious case of Sunspot Active Region 2720. It was indeed showing a bright leading edge, matching its southern counterpart. Such mixing isn't uncommon around the time the solar cycle flips. A strike in the 4 category, but its latitude is still pretty low. A strike against. Another anomalous spot seen this past April also seems to have belonged to the next solar cycle. One thing is for certain, the sun is a fascinating subject of study and will continue to surprise. Keep those solar filters handy, watch those magnetograms online, and we'll see what AR 2720 does when it comes back around the solar limb in about 12 days. That's back in August, though, folks. Our thanks to astronomer Carl Badams at the U.S. Naval Research Laboratory, helping us explain the process of identifying the sunspot solar cycle membership. All right, solar cycle 25. Next, InSight mission overview. NASA Mars InSight overview. Did you know that on Monday, NASA had a mission landing on Mars called the InSight? They do. InSight, short for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport, is a Mars lander designed to give the red planet its first thorough checkup since it formed 4.5 billion years ago. It is the first outer space robotic explorer to study in depth the inner space of Mars, its crust, mantle, and core. Studying Mars' interior structure answers key questions about the early formation of rocky planets in our solar system, and this all begins this Monday, November 26, 2018, when the InSight mission lands on Mars. Studying Mars' interior structure answers key questions about the early formation of rocky planets in our inner solar system, Mercury, Venus, Earth, and Mars, more than 4 billion years ago, as well as rocky exoplanets. InSight also measures tectonic activity and meteorite impacts on Mars today. The lander uses cutting-edge instruments to delve deep beneath the surface and seek the fingerprints of the processes that form the terrestrial planets. It does so by measuring the planet's vital signs, its pulse, seismology, temperature, heat flow, and reflexes, precision tracking. This mission is part of the NASA's Discovery Program for highly focused science missions that ask critical questions in solar system science. First CubeSat to deep space. The rocket that launched InSight also launched a separate NASA technology experiment, 2 mini spacecraft called Mars Cube 1 or MARCO. Coincidence. These briefcase-sized CubeSats fly on their own path to Mars behind InSight. Their goal is to test new miniaturized deep space communication equipment, and if the Marcos make it to Mars, may relay back InSight data as it enters the Martian atmosphere and lands. This is the first test of miniaturized CubeSat technology at another planet, which researchers hope can offer new capabilities to future missions. If successful, the Marcos will represent a new kind of communication capability to Earth. InSight's success is independent of its CubeSat tag-alongs. InSight Science Goals. The InSight mission seeks to uncover how a rocky body forms and evolves to become a planet by investigating the interior structure and composition of Mars. The mission will also determine the rate of Martian tectonic activity and meteorite impacts. Science Goals. Science Goal 1, understand formation and evolution on Mars. Science Goal 2, determine the level of tectonic activity on Mars. The InSight Mars lander has 2 science objectives that support the mission science goals. Formation and evolution. Understand the formation and evolution of terrestrial planets through investigation of the interior structure and processes of Mars. Tectonic activity. Determine the present level of tectonic activity and meteorite impact rates on Mars. Why Mars? Previous missions to Mars have investigated the surface history of the red planet by examining features like canyons, volcanoes, rocks, and soil. However, signatures of the planet's formation can only be found by sensing and studying its vital signs far below the surface. In comparison to the other terrestrial planets, Mars is neither too big nor too small. This means that it preserves the record of its formation and can give us insight into how the terrestrial planets formed. It is the perfect laboratory for which to study the formation and evolution of rocky planets. Scientists know that Mars has low levels of geological activity, but a lander like InSight can also reveal just how active Mars really is. So, starting this week, starting tonight, an introduction into the InSight mission, NASA. InSight, mission to Mars. I'll add on to this what I do know, that once the lander lands, it has a unique set of instrumentation, which are robotic in nature, but remain attached to the main lander itself. It has a tool that can bore a hole, I believe, 18 feet deep. He said, well, how would they do that? From what interpretation I saw, it was like a flat plate. It would go out onto the surface. Then out from the bottom of the flat plate would come this appendage. And the appendage is the drill, and it drills and it drills, and it can go 18 feet or some depth that has not been reached to date, a good depth. Well, they'll examine what comes out of the hole. And then they have the other instrumentation package, which relates to tectonic activity. We're on a break. Come back for the last segment of Collision Course on November 24th. It's 6:28 here in Cyprus, 7:28 in New York City. I'll see you in a few minutes.
listening to Revolution Radio at freedomslips.com, and we'll be right back after this message.
Wadiya will remain a dictatorship. Oh, be quiet. Why are you guys so anti-dictators? Imagine if America was a dictatorship. You could let 1% of the people have all the nation's wealth. You could help your rich friends get richer by cutting their taxes and bailing them out when they gamble and lose. You could ignore the needs of the poor for healthcare and education. Your media would appear free, but would secretly be controlled by one person and his family. You could wiretap phones. You could torture foreign prisoners. You could have rigged elections. You could lie about why you go to war. You could fill your prisons with one particular racial group, and no one would complain. You could use the media to scare the people into supporting policies that are against their interests.
Tune in Monday through Friday, 4 p.m. Eastern Time, for Liberation Nation with Deacon John, where America comes to hear the truth.
I know this is hard for you Americans to imagine, but please try.
Ohio Exopolitics will be on from 4 to 6 p.m. Eastern on Studio A. Mark Schneider will have guests on that will discuss many important topics, including the state of the world today. However, much of the show will be dedicated to the writings of Edward Albert Meyer. Let me read a short passage from one of his writings. Love is the highest principle of creation, and through it, everything exists in absolute logic. All of nature in its indescribable splendor is nothing but the love of creation, which is expressed visibly. The love of creation is everywhere, because without it, nothing at all would be able to exist. Please join Mark on Ohio Exopolitics from 4 to 6 p.m. Eastern on Studio A.
It is no secret that the so-called mainstream media is best described as controlled propaganda. Countless news stories are either totally ignored or spun with half-truths, and because of this, essential facts and vital information are often compromised. Join Dr. Ott every Friday night on Studio B at 10 p.m. Eastern and learn why The Story Behind the Story was nominated for a Peabody Award in its second year of producing unparalleled broadcasting excellence in 1997. That is, if you really care about learning the truth.
Transcending time and space, let us take you to the place inside your mind where thoughts divide and mysteries unwind. Join us every Monday evening right here on Revolution Radio at freedomslips.com from 8 to 10 p.m. Eastern Time. And you will catch the Fenton Perspective with our great host, Lorian Fenton. Come listen in as she shares her amazing stories from the past to present, along with all of her guest secrets to the future. That's the Fenton Perspective every Monday evening right here from 8 to 10 p.m. Eastern Time, only on Revolution Radio. Oh, and you don't need to expect us. We're already here.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Good evening, everyone. It's the last segment of Collision Course tonight for November 24, 2018. It is 7:34 p.m. in New York City, 6:34 p.m. where I am. We were just talking before the break a little bit about the NASA Mars mission called InSight. Let's go over a little bit more data that we can just scroll down and read to you something about it. Right now, as I'm reading this, the spacecraft is traveling toward Mars. Packed within that spacecraft is a mole. It's not a real mole, though. It's a robotic mole. It doesn't look like a robot, though. It looks more like a jackhammer attached to a long cable. And the purpose of this robotic Martian mole is to dig. We've dug into Mars before. Curiosity has been digging holes on Mars for years. It's discovered dirt. And it says now somebody give it a cookie. But unlike Curiosity, the mole isn't going to dig a few inches down. It's set to dig up to 16 feet beneath the surface. And it's looking for something we've never tried to find before. Something encased in total darkness, something beautiful, something new, but they'll get to that in a little bit. The mole can wait. The mission is not years or months away. It's close. It's days away. It will land on the red planet on Monday, November 26th of this year, Cyber Monday, or this coming Monday. This is the first interplanetary mission to launch from the west coast of the United States. It's also the first time we've touched down on Mars since Curiosity landed in 2012. But for this landing to happen, a lot of things have to go right. Fewer than half the missions to Mars make it. There have been 43 robotic missions to Mars from various space agencies. 18 have succeeded, 25 have not. Mars is an oxidized wonderland of scientific discovery, but it's also a graveyard of dead robots. And that's okay. This is not an easy thing to do. In fact, this is a hard thing to do. This is one of the hardest things you can do. The mission is called InSight. And as I said before, it is currently speeding toward Mars at 13,000 miles per hour. After covering 300 million miles in a total vacuum, it is going to hit the Martian atmosphere at an angle of 12 degrees. Any steeper and it'll burn up. Any shallower and it'll bounce off the atmosphere. Then it'll decelerate from 13,000 miles per hour to 1,000 miles per hour, pulling about 12 Gs in 2 minutes. If a 150-pound human were on board, 12 Gs would make them weigh 1,800 pounds. During deceleration, the heat shield will heat up to 2,700 degrees Fahrenheit. That's hot enough to melt steel. After that, it'll deploy a supersonic parachute. Then 6 tiny bombs will detonate and blast away the heat shield. Then 3 pyrotechnically deployed legs will pop out. After that, the lander will fall away from the back shell. Retro boosters will fire. And if all goes according to plan, InSight will touch down on the surface of Mars as gently as an inebriated butterfly. What's the phrases they use? This process of entry, descent, and landing will take about 7 minutes. During that time, NASA won't know if InSight has succeeded or not. This is known as the 7 Minutes of Terror, which is an appropriate title. This ephemeral moment requires thousands of processes to perform a perfect, autonomous dance. A dance preceded by years of calculation, engineering, testing, and retesting. A dance preceded by 1/3 of a billion miles worth of flight time. A dance requiring the lander to survive steel melting temperatures, rockets, pressures, parachutes, and bombs. A dance built on systems built upon systems built upon decades of innovation, mathematics, minutia, and pain. All of it culminating in 420 precious seconds of fear and wonder. All of it being watched by a group of talented, tormented NASA employees. all of it in pursuit of something beautiful, something new. The InSight mission is different from any other mission because it plans to study the interior of Mars. It's going to do 3 things. The first thing will be to use radio signals to precisely track how much Mars wobbles as it orbits the Sun. By monitoring Mars's wobble, we can tell what makes up the core of the planet. Then it's going to deploy a seismometer. This is going to monitor the seismic waves produced by Mars quakes and meteorite impacts. If Mars burps, rumbles, or gurgles, this device will detect it. Monitoring these waves will tell us the size of Mars's core and whether that core is liquid or solid. Lastly, it's going to deploy the mole. As I said before, this mechanical jackhammer plans to drill down 16 feet beneath the surface of Mars. This is the deepest we've ever dug on another planet. Human beings are creatures of sight. Vision is our primary sense. Because of this, most of our experiences are filtered through our eyes, a gelatinous pair of orbs perched in our skulls that internally televise to us sumptuous visions of sandwiches, sunsets, clouds, and corn dogs. Because of this, the world is beautiful. Because of this, the word beautiful is mostly applied to things we can see. The pillars of creation are beautiful. Saturn is beautiful. Jellyfish are beautiful. Even cell division could be called beautiful. Even the mantis shrimp is beautiful. InSight is not looking for this type of beauty. It is looking for an allure that goes unseen, one buried deep down in the dark, an object whose elegance doesn't come from seeing it, hearing it, or touching it, only knowing it. InSight is looking for the most beautiful object in all of the sciences. It's looking for a number. That number is buried within the incendiary stomach of Mars. It is a simple number, a pure number, an integer you could easily count to, and that number answers a very simple question. How hot is the inside of Mars? The mole is essentially an interplanetary thermometer. After digging beneath the surface, it is going to measure how much heat is escaping Mars' interior. This data might not sound particularly glamorous, but it has the potential to fundamentally change our understanding of how Mars formed and, by extension, how Earth formed. This innocuous little number, along with a handful of other marvelous integers from the seismology and axis data, could tell us how rocky planets evolve. InSight could transform our understanding of how Earth changed from a gurgling, angry lava ball into a lush, luminescent oasis of sandwiches, sunsets, clouds, and corn dogs. Furthermore, it will tell us if Mars is still warm enough for there to be pockets of liquid water beneath the surface. This would be incredibly meaningful because if there's one thing we know about our own planet is that finding liquid water means finding life. InSight will pass through Mars and show us things we've never seen before. It'll transform our monochromatic comprehension of the red planet into a tetrachromatic one. It'll show us something beautiful, something new. And that's the end of that description and interpretation and operational awareness for the NASA Mars mission InSight and what it's going for, what it's looking for, the heat from Mars, the seismology from Mars. Is it tectonic? Is there earthquakes? Is there meteorites hitting the surface? Does it ring like a bell? Does it shake like a mountain? Does it move mountains? Does it have water? What's the heat? What's the core? Seems like all our missions of the day are interested in the whats, the whens, the wheres, the hows of the science that's missing in our information base. You know, for as much as science knows, science doesn't. For as much as we believe in science, we have a lot more to believe in that we have yet to hear. New science will or maybe change the science as we know it today. I believe it will. I believe in the research and investigation of plasmas, electromagnetism, the sun, particle acceleration, energetically neutral atoms, the interaction of space weather at the edge of the heliosphere, all play a major role in how our Earth maneuvers its way through this solar system and the galaxy that it is a part of. Marco Velli, from the Parker Solar Probe mission, took a moment to talk about the heliosphere and its role in the galaxy and its movement through the inner stellar medium and galactic electromagnetic fields. Electromagnetism plays a major role in how the planets maintain their stability besides gravity. I believe that future revelations will be more inclusive to electricity and a closer relationship between gravity and electricity will be revealed and understood and mathematically detailed, peer-reviewed papers so that the researchers like ourselves can come back and have a better understanding of exactly what's occurring and how our sun is operating the way it operates, how Earth can protect itself. It's all about future. It's all about the future. Man's need to know or have an idea of what will happen to him in the future begins with the sciences of the day. Science can wreck your day. If you rely on bad science, you can have a bad day. And while many proponents of certain sciences get the most reviews and attention, we have to understand that by placating certain scientists and their beliefs in the way that they believe them may not be doing us very much good in the future. It may hold us back. I know that a lot of the number one scientists who are the most to be seen are the ones who say everything with the big fat smile on their face, as if they know something that they're not reporting to us. When I have conversations with people and conversations about science and astronomy, I like there to be a seriousness, sort of. I like to have fun and find out new things, but I like there to be a seriousness about it because the information is important. When I can watch a video or read a review or an article that is quoting science, science, the leading scientists, the leading marketing scientists relating information to the public, they shouldn't always do it with a big fat smile on their face because it just seems like they're hiding something. I know that over the past 7 weeks, 8 weeks, my knowledge base has increased greatly over the topics that we've covered. With Oumuamua, repetitive coverings have uncovered repetitive layers of information that makes the whole story very, 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 very interesting. We had a talk with Dr. Fuselier about the energetic neutral atoms, who he's friends with Dr. Dave McCombs, who we talked with Marco Velli about tonight with the IBEX mission. energetic neutral atoms, when you find them, you know that somewhere in their life there was an interaction between themselves as an energetic particle with a interaction with another energetic particle, and in that interaction, boop, that collision, the energy gets stripped from one of the atoms and it starts heading back the other way. And it's a method of measuring where these highly energetic areas of the space around our heliosphere is located. So we've learned enormous amounts. Renu Mohatra and the search for Planet 9 and the search for Planet 10, we're going to get back on that because we're going to be pointing backwards out in those areas. Can we discover those unfound planets? Cosmic Obsession Kerrville will be pointing its telescope where Oumuamua came from, in the event that there may be more on their way from the same place that Oumuamua came from. But we have to keep in mind what Avi Loeb said about the peculiar relationship of Oumuamua's speed with the stars in the area around our sun. But we're going to look more into that and talk more about that when we start taking images of the area of where Oumuamua came from. We want to thank all the Citizen Space Force members, all the enrollees, all the enlistees, all the commended officers. Come to collision course. Hear what's going on with the fleet. These are the missions that we're most interested in. These are the missions that we'll continue bringing your briefing to you with. We want to thank all of you for being a part of the Citizen Space Force. We want to thank you for being a part of the Collision Course Facebook page, the interactions that I have with you and you have with me over the topics that we all enjoy. That's outer space, the space outside our atmosphere. Sometimes it brings us inside our atmosphere when there's something hanky-hanky going on the ground. We'll visit those topics, but we do like to mostly stay out in space. And that's why we have the show, Collision Course, every Saturday night from 6 p.m. to 8 p.m. New York time. Studio B on revolution.radio. Revolution.radio is a solely listener-supported radio station. Revolution.radio is free speech at work. If you're able and you're listening to Revolution.radio, please click on a donate button. There's also a page where we offer things for sale. Seed packets, silver, things that you want if you're someone like me. Go there. Support the station one way or the other because free speech does cost. It costs. But we want to thank Nighthawk and the crew over at Revolution.radio for offering us a place to speak freely. Our free speech, our truth, just happens to be about outer space. Next week, I believe that I'm going to have some of my interviews put together and we can go over the highlights or the things that I hadn't heard before. Maybe we'll have it a night like that. The things I hadn't heard before show next week. 12/1, December 1st. We have over this past week, we know we've seen some information about the Spitzer telescope taking a look at Oumuamua and finding nothing. Is it surprising to me? Do I want to say, oh, that makes it so small? Like, you know, the interpretation of that is that, well, then the object must be very, very small or highly, highly reflective. I mean, imagine a mirror flying through space. It'd be very hard to see it because it would just reflect stars, or if it was small, too small, like they say, or if it just wasn't where they thought it was. If it wasn't what they thought it was, then you would definitely not see it. So, but that hasn't been proven or disproven one way or the other. Over the next week, I'm going to be diving into the orbital elements of Oumuamua, and I may find myself awash in quicksand because none of the numbers may be right, because they're obviously having a hard time tracking it, and they want to say that there's camouflage on the way in, and they can't find it. So we're really going to keep going with Oumuamua because the information is still fresh and hot and tasty. And so we'll be looking at the orbital elements because I have to hand them over to Cosmic Obsession Kerrville so that they can begin their survey of the origins of Oumuamua. We're going to hopefully, over a period of time, we're not going to try to do this all at once. It could take months, or it could take weeks, or take how much time it takes. We'll hopefully take an image of that space and then double it up with another image a week or 2 or 3 later, and then another image. And we're going to start layering images over, and we're going to start looking for things to move. And are there things moving in that space? Is there something that we need to be paying attention to? I believe we have plans maybe to look at it with the Takahashi Apo great telescope wide field. That's an update from there. Scroll down a little bit. That's more okay. New news this week was the Doom Star in the Milky Way threatens a rare gamma ray burst. Information that's relevant regarding gamma ray bursts. This week came out some information that science has discovered star triplets. You got a binary star system orbiting each other with a third triplet star around it. They are orbiting so fast and with such strength, they are disturbing the space-time around them. It's interpreted, it almost looks like a yin-yang feature, but it's just the whipping around of the stars around each other, creating this space. And the science says that one of the stars could be very close to
or will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at buyer risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps.